In this lesson, we're going to learn how to test a claim about a proportion. There are several methods for testing a claim about a proportion. We're going to be using the p-value method in this lesson. There are also critical value methods, or it's sometimes called a traditional method, and a confidence interval method that you can use. The requirements for testing a claim about a proportion are that the sample observations have to come from a simple random sample, and the conditions for a binomial distribution must be satisfied. Here's some notation that we will see. Lowercase n represents the sample size or number of trials. The sample proportion is p hat. P hat can be found by dividing x over n, where x is the number of successes out of n total trials. Sometimes p hat is explicitly given to us in the problem as a percentage. The population proportion is denoted as regular p. This is used when we set up our claim statement. It is also used for the null hypothesis. Q is the complement of p. To solve for Q, we subtract the claim from 1. The formula that we will be using in our hypothesis test involves solving for a test statistic. The test statistic is denoted as z, and it equals p hat minus p divided by the square root of p times q divided by n. Here's our first example. In a survey of 703 randomly selected workers, 15.93% got their jobs through newspaper ads. Consider a hypothesis test that uses a 0.05 significance level to test the claim that less than 20% of workers get their jobs through newspaper ads. So the first thing I want to do is set up my claim in symbolic form and my two hypotheses. So before we even do the hypotheses, we need to start with the claim. If we look at the claim statement, we're testing the claim about a percent. When it's involving a percent, we use a p. And the claim states that we want to test the claim that it is less than 20%. So that would be p, population proportion p, less than the decimal equivalent of 20%, which is 0.20. So it follows then that our null hypothesis, h sub 0, is p equals 0.20. The null hypothesis is always equal, and it will always use the same value that we use in our claim statement. The alternative hypothesis is going to match the claim here. So the alternative, h sub 1, is p is less than 0.20. Once you have set up these statements, it's important to also note if you have a one-tailed test or a two-tailed test. If you have a less than or greater than in your claim, it is a one-tailed test. And specifically, this is a left-tailed test. So that means when I set up my diagram to graph the test statistic and solve for the p-value, the p-value is going to be the area contained in a left tail. Now let's solve for the test statistic. Our formula is z equals p hat minus p divided by the square root of p times q over n. Now p hat comes from the sample percent. If they give you another percent that is different from the claim percent, then that is going to be p hat. Always do the decimal equivalent of what you see, so you have to move two places to the left. So p hat is 0.1593, our sample proportion. We want to subtract our sample proportion. We want to subtract p from it. Now p is the claim. So the value that we're using up here with our claim and our hypothesis statements is the value that goes here for p. And remember that q is 1 minus p. So q is 1 minus 0.20 or 0.80. N is the total number of trials, or the total number of people in our survey, and N for this problem is going to be 703. So here's my Z test statistic. 0.1593 minus 0.2 divided by the square root of P times Q. So notice that this is carrying down the same claim value. 0.2 times 0.8 divided by 703. These two values, the 0.2 and 0.8, must add up to 1. To type this in the calculator, here's a suggestion. Do 0.1593 minus 0.2 and then press equals. Now hit divided by, get your square root, so you might have to do second and hit your x squared button to get your square root symbol. And usually the square root comes up with a parentheses. Inside type 0.2 times 0.8 divided by 703 and then close it off. So notice inside I'm not using the parentheses at all. I'm using my times sign for the product and then automatically dividing by 703. Press equals. Since this is a Z, Z's always round to 2 decimals. So this is going to give me a Z value of negative 2.70. The next step in my hypothesis test could be to find the critical value, but it really isn't necessary for this type of hypothesis test when we're testing a claim about a proportion. So I'm going to skip the critical value. So now we're going to go into finding the p-value. Now the p-value is the area that's located in the tail that's beyond the test statistic. If you remember from the very first step, when I set up my claim and my hypothesis statements, my claim stated that p is less than 0.20. So since it's a less than claim, I have a left-tailed test, and my p-value is this area in the left tail. Now the mark that's on the line here is going to be where my test statistic is positioned. So you can draw a diagram for every single one of these problems to give you a visual to help you understand where the p-value is. My test statistic that I just solved was negative 2.70. So that is going to be the mark right here on the curve. Now this is a Z, and so we have a Z table that we're going to look up this value in. So let's go to the Z table and look at negative 2.70. So I'm looking at the negative 2.7, I'm looking at the negative side here, and the hundredths position is 0, so I'm looking at this first column here and joining that together. And so this gives me 0.0035. This is the area that's contained under the curve to the left of the Z. That's the way this particular Z table is set up. So the area to the left is 0.0035. So now let's go back to our picture. And I now know that the area to the left of negative 2.70 is 0.0035. So that's my table entry, and I don't have to adjust that at all. That is exactly what my p-value is going to be. So my p-value is 0.0035. Okay, so now that we've figured that out, we can go to the conclusion. Now the conclusion begins with deciding whether to reject the null or whether to fail to reject the null. We never conclude to support the null. So that's the first step, is to figure out if we're rejecting or not. So first, the claim is that p is less than 0.2, or in plain words, that less than 20% of workers get their jobs through newspaper ads. Now, if the p-value is less than or equal to alpha, we decide to reject the null. Now, alpha then is the significance level of the test. So there's one number here that we haven't used yet. It's the 0.05. The significance level gives us alpha. So alpha is, for this test, 0.05. So what I want to do next is I want to compare the p-value that I got to alpha, and I want to know, is the p-value greater than or less than alpha? So the p-value that we found was 0.0035, and I'm comparing that to 0.05. If you just compare the hundredths positions, 0.00 and 0.05, you can see that the p-value is less than alpha. And so if we have p-value less than alpha, then we decide first to reject the null. So I have a table here that helps me determine the wording of the final conclusion. Reject the null is not the conclusion. You have to form a conclusion using the words below, and you have to reference the original claim when you do this. So if we reject the null, I'm going to come over here, and first we have to figure out if the first two say, does the original claim not include equality? That's what these first two say, not including equality. That means, does your original claim have a less than or a greater than or a not equal? If it does, then you're looking here to figure out your conclusion wording. The last two say, does the original claim include equality? So if your claim has an equals in it, you're looking here. Now my claim had a less than in it. So yes, I would be looking either here or here. Now the original claim does not include equality, so did I reject the null or did I fail to reject? And in this hypothesis test, we rejected the null. So I'm going to set up the wording of my conclusion using the statement, there is sufficient evidence to support the claim that, and then you will reference the original claim. So there is significant evidence, or you can say sufficient evidence, to support the claim that less than 20% of workers get their jobs through newspaper ads. So this is the conclusion we're looking for here. So to follow up, based on those results, can we conclude that 15.93% is significantly less than 20% for all such hypothesis tests? The answer is no. So the difference between the sample proportion that they got when they did their survey, it is less than the claim that it's less than 20%. But if we change our sample size, that can affect it. So the difference between 15.93% and 20% may no longer be significant if the sample size is smaller than the large sample that they had in this problem. So now let's look at another hypothesis test. This is a good one to practice, so if you watched the previous video, maybe you should pause this right here after you read this and try to go through the steps on your own. Okay, among 734 randomly selected internet users, it was found that 360 of them use the internet for making travel plans. Use a 0.01 significance level to test the claim that among internet users, less than 50% of them use it for making travel plans. And are the results important for travel agents? So we do have this follow-up question here. So the first step is maybe looking in the problem, and we want to set up the claim first using symbols. So let's go ahead and do that now. So what is the claim? We're testing the claim that. So following this statement, this is what you're focusing on. Among internet users, less than 50% of them use it for making travel plans. So see the less than and see the percent. So we use a P because it's a percent, and we use less than, and we convert 50% to 0.5. So my claim is P is less than 0.5. In plain speech, less than 50% of internet users use it for travel plans. Once we get the claim set up, we want to do the null hypothesis and alternative hypothesis. So if my claim is P is less than 0.5, then my two hypotheses will also use the 0.5 in it. And remember that the null is always equal. So the null hypothesis is P equals 0.50. The alternative then is going to be matching the claim. So it's p is less than 0.50. At this point, make a note to yourself what type of test this is. Because it's a less than test, we have a left-tailed test. And so when I set up my picture, I'm solving for the area to the left of my test statistic z. My p-value is going to be contained in that tail. Okay, so now let's find the test statistic. So the formula is z equals p hat minus p divided by the square root of p times q divided by n. Now the p that's here is the claim. And so my claim and my hypotheses use 0.5. And that is going to be the same value p that's used under the radical. Q is 1 minus p, so Q is 1 minus 0.5, which gives you 0.5. So p and q are both 0.5. Now to solve for p hat, we're going to have to look back and either find a different percent that's not 50%, or find two numbers that you can divide. In this problem, we have a total of 734 people were selected, and then it was found that 360 of them used the internet for making travel plans. These are my two numbers that I can divide. P hat is x divided by n. So x would represent 360 internet users out of 734, or 360 used it for making travel plans out of 734 total internet users. Okay, so next we're going to divide those two values. So 360 divided by 734 is 0.49046. Now I would recommend on these be generous with your decimal places here. You don't want to round off to two places until after you've solved the formula. So you'll see sometimes when you're working out problems that maybe your test statistic is a little bit off, and it could just be because you didn't round to enough places. Like if I said p hat is 0.49, I will get a very different test statistic compared to if I say p hat is 0.49046. Okay, so let's see how we set it up here. I chose here to round it to 0.4905, so 4 or 5 places is usually going to be enough. So I have 0.4905 minus 0.5, so I'm going to type that in my calculator, press equals, and then press divided by square root, 0.5 times 0.5 divided by n, and n is 734. Close that off and press equals. Always round z to 2 decimals. So z is negative 0.52. Okay, so next, to find out the p-value, let's draw a picture and then look up our z. So my normal distribution curve, remember, is a left-tailed test. I got z is negative 0.52. That's my test statistic. And my p-value is going to be the area located in this left tail. So now I have to look up z in table A2. So I'm going to go to my z table and look up the negative 0.52. So in my z table, I'm looking at the negative side, and I'm looking for negative 0.52. So that's going to be down here, negative 0.5, and I want to go to the hundredths position of 2, so that's the third column over. So I'm going to join that together, and I get 0.3015. That is area to the left of the z. Okay, so let's go ahead and go back to that problem. Got a little bit off there. And put that in to our next step. So this is a one-tailed test because of the less than. We looked up z is negative 0.52 in our z table and found that the table entry is 0.3015. So since our claim is less than and it is a left-tailed test, that is our p-value. It's area under the curve to the left of the z. So now we want to form the conclusion, and we want to compare the p-value that we just got to the significance level of our test. For this test, they're using a significance level of 0.01. So they said in this second sentence, use a 0.01 significance level. So that's our alpha. So I reject the null if the p-value is less than or equal to alpha, and I fail to reject if the p-value is greater than alpha. So we got 0.3015 for our p-value. That's obviously greater than the significance level. So I would say fail to reject the null. So remember, that's not our final conclusion. That's just going to help us get the wording. So now let's look at how to word our final conclusion. So first, did our original claim include equality or not? Well, the original claim was less than, so I'm looking at either this or this. And then in my final step, did I reject the null or fail to reject? Well, since I failed to reject, this is the correct wording. So I would say there's not sufficient evidence to support the claim. So what's happening here is we have our null hypothesis, p equals 0.50, and our alternative hypothesis, which is p is less than 0.50. And remember that that matched the claim. So the alternative is the same statement as the claim. If I fail to reject my null statement, that means I can't reject it, so it could be true. And if this could be true, then I have not supported the opposite here. So that's why we say there's not sufficient evidence to support the claim. And then we want to reference what the original claim is. So there is not sufficient evidence to support the claim that less than 50% of all internet users use it for travel plans. Okay, so you actually want to reject the null hypothesis in most research studies because it does allow you to support your claim due to the wording. Now let's look at another example that will go from the less than to the greater than. So this is going to use a different wording here. So we want to look for that wording for setting up the claim statement, and then how is that going to affect the p-value that we look up. So the Pew Research Center conducted a survey of 1,007 adults and found that 856 of them know what Twitter is. Use a 0.01 significance level to test the claim that more than 75% of adults know what Twitter is. So I'm going to do all of the steps of the hypothesis test right here. The first step is to set up my claim and my two hypothesis statements. So my claim is, because it's about a percentage, I use p, and it says more than 75%. So that's greater than the decimal equivalent 0.75. My null hypothesis is always equal to the number, and my alternative then is going to match the claim, p is greater than. So at this step, I'm going to take note that this is a right-tailed test because it's greater than. So my picture is going to be having a test statistic that should be positive, and the p-value is area to the right of that. Now we go right into the test statistic formula. Z is equal to p hat minus p divided by the square root of p times q over n. So we know that p comes from the claim, so our p is 0.75. P hat is the sample proportion, so I need to go back to the problem and either find a percentage that's not 75% or two numbers that I can divide. On this problem, I see 856 out of 1,007 knew what Twitter was. So I'm going to divide those two numbers to find my sample proportion. 856 divided by 1,007 is 0.8500496524. So I would suggest going out to about 4 or 5 decimal places for the formula. So p hat is equal to 0.85005. I'll round it off there. Remember that q is the opposite of p, so q is 1 minus 0.75. So the Q in our formula is 0.25. Okay, so now let's go ahead and set up the formula and plug all of those values in. So I have p hat, which is 0.85005, minus the claim, which is 0.75, divided by the square root of the claim, again, 0.75 times 0.25, divided by the total in my sample, 1007. Okay, so don't forget to type the numerator in, press equals, divide by square root, and then do 0.75 times 0.25 divided by 1007. The value that you get needs to round to 2 decimals. Z is always 2. So I get Z is equal to positive 7.33. Okay. So my third step now is to find out what the p-value is and draw a picture. So I draw the picture of the normal distribution curve. I plot Z, which is positive 7.33, so that's going to be way out here to the right. And I want to find greater than for my claim, so I'm solving for area in this right tail. So my p-value is area to the right of 7.33. So now I need to go to my table A2, and I'm going to look up 7.33 in my Z table. Okay, so let's go ahead and do that step next. Go to the Z table, look up positive 7.33. Okay, so that's off the charts here. 3.50 and up is an area of 0.9999, but remember that's area to the left of the Z. So look at all of that area. That's not what I want. I really want area to the right. So when you have a right-tailed test and you look it up, you're going to have to subtract what you get from 1. So area on the other side is 1 minus that. So that's going to be 0.0001. That is my p-value. Okay. Fourth step is we're going to compare the p-value to alpha, the significance level of the test. We want to use a 0.01 significance level, so alpha is 0.01, and our p-value is 0.0001. If you compare the hundredths position, you can see that the p-value is less than the significance level. So now that lets me go into forming the conclusion. When the p-value is less than alpha, we reject the null. Okay? So now let's figure out the wording that we need to form this conclusion. We know we're going to reject the null, and we know that our original claim was greater than. Okay, so to get the conclusion, if the original claim does not include equality and we reject the null, so we're looking at this first row here, we say there is sufficient evidence to support the claim that. Okay, so let's go back to that step here. So if I reject the null, what's happening back here is I am throwing out the null, and if I throw out the null, that leaves me with the alternate. So I've supported my alternative hypothesis, and since the alternative matches the claim, therefore I've supported the claim. So my sixth step is my conclusion. So I'm going to say there is sufficient evidence to support the claim that, and you got to look at the wording. So it says test the claim that more than, so I'm just going to copy that, more than 75% of adults know what Twitter is. So you just have to copy what that statement is. So that is my final conclusion. Okay, so now that you've seen all of the steps for a complete hypothesis test, and this one involved a greater than, so remember if it's a more than claim, you're going to have to subtract the area that you get from your table from 1 to get the correct area under the curve. Now let's look at one more hypothesis test. This one's going to involve a claim that has equality. Voting records show that 61% of eligible voters actually did vote in a recent presidential election. In a survey of 1,002 people, 70% said that they voted in that election. Use a 0.05 significance level to test the claim that the percentage of all voters who say that they voted is equal to 61%. Okay, so first step is I'm going to write the claim using symbols. And so since it's a claim about a percentage, I'm using P. And we want to test the claim that the percentage is equal to 0.61. Now my null hypothesis is always equal to the value. So then this time I have to come up with something else for the alternative. It cannot match the claim. So the alternative has to be not equal. When the claim involves equality, this is a two-tailed test. So that means when I set this up and I get my test statistic, I'm actually going to be looking at the negative and the positive value of the z, and the p-value is the combined area in those two tails. Second step is to solve for the test statistic. So z is equal to p hat minus p divided by the square root of p times q over n. So the p, remember, is from the claim. So for this example, the claim is 0.61. And q is 1 minus p. So 1 minus 0.61 is going to give me the q, which is 0.39. Okay, so now let's find p hat. So to find p hat, we look in the problem for a percent that's different from the 61%. So when I'm reading here, see another 61%, I cross that off, and I see 70%. So in this trial, they found that 70% said they voted in the election. That is my sample proportion. So the decimal equivalent of 70% is 0.70. So to plug into the formula, we get p hat minus p, so 0.70 minus the claim, divided by the square root of the claim times q, the opposite of the claim, 0.39, divided by n, and the total in the sample was 1,002. Always round z to 2 decimals. So z is equal to positive 5.84. Okay. Third step is to figure out the p-value. So I'm going to draw a picture now. And because this is an equal to claim, I have a two-tailed test. So really what I have is I want to plot positive 5.84 and also the negative 5.84. So with symmetry, we have the two signs of the test statistic going on. And the p-value is the combined area in both of those tails. So you have a choice on which one to look up. If you look up the positive, you're going to have to subtract from 1. But if you look up the negative sign, then the answer you get is area to the left. So I would advise to look up the negative test statistic, because then you don't have to subtract it from 1. So let's go ahead and look that up in our table. And we want to find negative 5.84. So I'm looking at the negative z tables, and I'm looking for negative 5, and then that's off the chart. It says negative 3.5 and lower, the area is 0.0001. So now that I've figured out what that area is going to be, I can go to my picture, and this side is going to be 0.0001, and because of symmetry, I know that this tail contains the same amount, 0.0001. So my p-value is 2 times 0.0001, or 0.0002. Okay, so now the third step, or fourth step, is to figure out if we reject the null or fail to reject the null. So we're going to compare our p-value to the significance level alpha. We're using a 0.05 significance level, so alpha is 0.05, and our p-value is 0.0002. Now that's less than 0.05. So because p-value is less than alpha, we will reject the null. So the fifth step is to word the conclusion. So if we reject the null, we come up here to the null and we reject it, we throw it out. If we throw it out, then that leaves us with our alternative hypothesis. Now the alternative does not match the claim, so we're not going to be able to say we're supporting the claim this time. Our wording is going to be very different. So let's look at the wording for the conclusion that involves equality and we reject the null. So if your original claim involves equality and you reject the null, you're on this third row here. You would say there is sufficient evidence to warrant rejection of the claim that. So notice the wording is very different with the claims about equality. Okay, so I just need to start with that statement. There is sufficient evidence to warrant rejection of the claim. So we actually did reject the claim. When we rejected the null, we threw out the claim as well. So we want to reject the claim, so I look up here for the wording, that the percentage of all voters who say that they voted is equal to 61%. So that's telling me then that it's not true that the percentage of voters who say they voted is truly 61%. So maybe people are inflating that value and they're not being as truthful as they could be. So we've looked at several different examples in this lesson of how to set up a hypothesis test for claims involving a population proportion. We've looked at two of them that had a less than claim. We looked at one that had a more than and another that had an equals. So now you need to do some follow-up practice problems from your homework or from any sample problems that I provided you just to go ahead and get the practice on your own.